Demo video. KalmanGuard is an AI assistant protection layer for Uniswap v4 liquidity providers on Sepolia. It monitors pool conditions like price, volatility shifts, and manipulations MEV signals, runs a Kalman filter risk model, and turns that into on-chain actions through Uniswap v4 hook. It can dynamically adjust fees and trigger emergency control based on the risk. It is for LPs and pool operators who want safer liquidity provisioning and better risk management without manually watching markets 24 by 7. It delivers a live dashboard agent system that produces risk score in real time and verifiable on-chain proof transactions events showing those risk updates are applied to the hook contract. Of the contracts. This will take few much time. After it complete, you will get two addresses which you will have to paste in your .env file here. Then we can proceed further. And we will also start one terminal for the logs. Redis monitoring are up now. And also we have checked their health. This is a live backend state snapshot from API state. You can see the pools, Kalman parameters, and risk scores and agents all returned as structured data. Now I will opening the same state in the browser, and that will be the same API state endpoint just rendered by the UI, and just we need to notice the timestamp here so we can see the difference there. Okay, this is the different timestamp we can see here, and the values are changed, the velocities are changed, the risk scores are changed. Here risk score is 15, there was 23. Also the prices have also changed. So our system is working on the real time, providing us the risk scores and the velocity. Velocity here is the volatility of market basically. How fast it's changing the prices. Okay, the each data was from three pools: ETH USDC, ETH WBTC, and USDC USDT. Prices are updating continuously, risk score is computed in real time, each pool updates independently. These timestamps proves that, and our system is live, not static. UI also reads the same as the backend state and it updates continuously. And the risk is derived by the Kalman velocity, acceleration, volatility, and the confidence. Even small price change can shift the risk early. Now I will be injecting price update directly into the Kalman engine. This is new observed price. The engine immediately computes the market dynamics. From that, it derives the confidence and a real market risk score, and it also computes a fees recommendation. This response comes straight from the engine, not the UI, no agents, just pure the model output. Here it have computed the risk, volatility, and the fees recommendation. Kalman engine exposes its internal state as Prometheus matrix. Here's the live price. And here the computer risk score, the same one as just we saw in the engine's response. This allows us the real-time monitoring alerting and the dashboard without touching the application code. We can verify here everything is same risk score. So the same update produces three things: a model response, a state update, and live metrics running locally. Everything you see here is driven by the same backend API we just queried from the terminal. We can see the dashboard. Here we have three pools as we seen the earlier at the terminal. Analytics. We have agents, risk scoring agent, execution agent. We also have settings which we can use. Let's go for a demo. I'm connecting my wallet. It's connected successfully. I would like to tell that all the agents here are getting their status and metrics from the backend in real time. For the final proof, I will show KalmanGuard writing and reading live data on Ethereum Sepolia. This confirms I am connected to Ethereum Sepolia chain ID 1115551. It's my address where the contracts are deployed through. Okay, currently I'm having 0.1169 Sepolia. I have called agent controller contracts heartbeat string function with the label KalmanGuard demo heartbeat. The terminal prints the transaction hash that is our verifiable proof on chain. And next I will, we can see here the transaction receipt. Here the heartbeat function was called and it's the transaction receipt. Now I'll show you the transaction hash on the Sepolia Ether scan. We can verify here it's successful. We can also see the logs. It was our heartbeat function. And we can also verify it from our deployment account. It's successful. And this receipt confirms us that the transaction was mined. Now I have called update risk score on the hook contract. This writes the new risk score and regime on chain emitting risk update event. Here's the transaction hash and we have transaction hash and I will show you it on Etherscan. And we can see it's successful and I will also show you the logs and we can see it, yes, it's successful and we have new timestamp also. Here the risk score was 90% and the regime was 3. Thanks, this is all for our project. And these are the addresses.